Okay, this is UBC Math 100 Past Final Exam 2015, question number 8. And take a look at the question here. We have a tank of water, shape of an inverted circular cone of height 16 meters and diameter 20 meters at the top, being filled with water at a rate of 2 meters cubed per minute. And you can take a look at part A and B. They're kind of related, so you can't really do not just one separate part from the other. They're both together. You want to draw a vertical cross-section and label it with all the lengths that appear in your solution to part B. And part B says to find the rate of change of the height of the water when the height is 10 meters. Okay, so first off, you might recognize this as a related rates question because we have some rates that we are trying to relate together. There's volume here, 2 meters cubed per minute. There's another rate of change. And to do that, what we want to do first is draw out the situation. So we're going to do part A first. Now, here's a shape of the cone. They give us what's going on. You can imagine this is the cone. And this is the water level, the top of the water level in the cone. That's, not filling up the whole thing yet. So let's try drawing this out here again. So here's our cone. And let's see, here's our water level. Okay. And we're given in the question that the height of the cone is 16 meters. That means this length here is 16. And also the diameter of the cone, that means the distance all the way across from its circular base is 20 meters. Meters and meters. We're also given in the question that it's being filled with water at a rate of 2 meters cubed per minute. That means the volume is increasing by 2 meters cubed per minute. If we denote the volume of this water by V, then we could say dV dt is 2 meters cubed per minute. Now, what do we need to find? We need to find the rate of change at the height of the water in the tank when the height is 10 meters. So the height of the water is this length, this distance here from the top of the water to the bottom. We can label that H. To figure out this relationship, we want to find our end goal is the rate of change of the height. So that means dH dt. And so that's going to equal to something. We need to figure that out. And we want to figure it out when H is 10 meters. Okay. So this is the setup of the related rates problem. We have a situation and we have our two rates that we want to relate together. And for a cone, the way we relate these two variables, volume and height, is through the volume of a cone formula. And the volume of a cone is given by 1/3 pi times the radius of the cone squared. So the radius is here, in this case, from the center to the outside, times height. This is going to be our equation. So I could write V is 1/3 pi r squared h. Okay. But here we can see we have this r, which we don't have any information about. And so we're going to have to eliminate this r from the equation so that it can just be between v and h. And then we can take the derivative to get to these rates. So how do we eliminate r? Well, we're going to have to use something about some relationship from this situation. And you might have to think about this for a while. But it turns out it's going to be the similar triangles here. And in particular, it's going to be this triangle. So you can draw up to the top and to the right, and then down on this diagonal. You could also use left diagonal as well, but I'll consider this triangle. And let me just draw it over on the side again, so we can more clearly see what's going on here. Okay, so it's a right triangle. And we want to measure some of the lengths. Here's the top of the water. Now, because we have this is being 16, that means this length is 16. So I could label here as 16. And this is H, right, from the water. We also have the radius, so that this is R. And this length here, we also know it's not the diameter, but it's the radius. So it's half of the diameter. That makes it 10. Okay. Now, what does similar triangle say? Well, it says that the ratio of corresponding sides are equal. So for example, this length on the big triangle divided by this length on the smaller triangle, so 16 divided by h, is going to be equal to the ratio of this on the big triangle to this on the small triangle, so 10 over r. Okay, so the ratio of big triangle to small is the same as big triangle to small. Very nice. So now we have a relationship between h and r, and now we're going to use this to try to eliminate r in the question, right? We want to eliminate r so that it would have h only left over. That means I want to solve for r in this equation. So I'm going to cross multiply to get 16 r equals 10h. Then to solve for r, we divide by 16. We get r is 10h over 16. You could also simplify this to get 5h over 8. Okay, so now we have r. So now I'm going to substitute it back into the volume equation. So instead of r, we're going to write 5h over 8. Now, here we want to simplify this before we take the derivative. First off, we're going to, for the number part, we're going to have 1/3 times pi, and then we're going to have 5 over 8 squared. Now, 5 over 8 squared, you can write that as 25 over 64. 1/3 pi. Okay, this is just the number part. For the variable part, we have h squared times h. That makes h cubed. For the number part here, you could multiply things together. For example, 3 times 64 is going to be 192. On the other hand, when we take the derivative, we're going to have a factor of 3 anyway, so it's actually going to cancel. So let me just leave the constant like this. Then we take the derivative with respect to time. Okay, so you could write it like this: d dt, d dt. And on the left side, we're going to have the derivative of volume with respect to time. On the right side, this is just a constant, so it's just going to come along for the ride. And then when we take the derivative of h cubed, we get 3h squared dh dt. Now again, the 3 is going to cancel out with the 1/3. So that the number part in front is we're going to have is 25 pi over 64. Okay, so just like that. Now, we want to solve for dh dt. Remember back in the question here? We know what dv dt is, and we want to solve for dh dt. So I'm going to isolate dh dt in this equation, so I can solve for it. The way I'm going to do that is I'm going to multiply both sides by 64 to bring this over here. And then I'm going to divide by everything here to put it in the denominator on the other side. So I'm going to have 64 dv dt divided by all this. So 25 pi h squared. Now all we need to do is substitute these two values, dv dt and just h. That's going to help us compute dh dt. Well, dv dt, if we go back to the question, is 2 meters cubed per minute. So I'm going to substitute in 2. And h is 10. Right? We want to find when h is 10. So we're going to substitute that in. 10 squared. Now, this could be your final answer, because it's a perfectly exact answer. If you want to simplify, well, let's see here. So it's a little bit tricky to do by hand. I'll just note that the final answer is going to be 32 over 625 pi. Now, if you just need the answer, this is a perfectly good final answer. This is a simplified fractional form. And also, if you have a calculator, you can substitute it in, and you'll get about 0.02 meters per minute. And that is your final answer. All these parts here. Okay, so let's just recap a little bit. So first, we drew out the situation. We figured out what rates we need to find and what rates we have. We figured out what equation would relate those two quantities, v and h. We eliminated one of the unnecessary variables by using similar triangles. That's what we did here. Then we took the derivative of both sides with respect to time. We solved for the quantity that we want to solve for. And then we substitute the unknown, or we substitute the values that we know. And we get our final answer. Very nice. Okay, well, that's all for this question. If you found this helpful and you're interested in a full solution guide for this entire past exam, as well as other past exams, then check out my solution guide in the link below this video. Thanks for watching, and I wish you the best of luck with your studies.